The drop-down menu. Complete the passage about Earth's interior. If the information is new to you, give it your best try.
Density is a ratio of mass to volume. Earth's two innermost layers are denser than the others based on their relatively low volume and high mass. When we examine the structures of the other terrestrial planets in our solar system, we see that their structure is similar to Earth's.
When we think of Earth, we might imagine blue oceans separated by lush green continents. While this might be the Earth we're used to seeing, it's not at all what Earth used to look like. For the first billion years after its formation, Earth was a harsh planet. After all, it faced a constant barrage of meteoroids, comets, asteroids, and other space debris. The planet's surface was similarly inhospitable. The continents were rocky and lifeless, the oceans were shallow and hot, the atmosphere was continents. While this might be the Earth we're used to seeing, it's not at all what Earth used to look like. For the first billion years after its formation, Earth was a harsh planet. After all, it faced a constant barrage of meteoroids, comets, asteroids, and other space debris. The planet's surface was similarly inhospitable. The continents were rocky and lifeless, the oceans were shallow and hot, the atmosphere was toxic and corrosive. During this early period, Earth looked like many of the planets we see in our solar system, dangerous and uninviting, but it was the events of these early moments in Earth's history that paved the way for our modern planet. Earth's accretion.
Meteoroids flying toward Earth during the planet.
Like all the other planets in the solar system, Earth was formed from the constant bombardment of rocky debris orbiting the Sun. We call this process accretion. Earth's gravitational pull sucked in these small rocky objects. As a result, Earth's mass and gravitational pull increased, which increased the frequency of the impacts. This process caused Earth to continually increase in size. The meteorites and comets that impacted Earth arrived with enormous speed. For a moving object, higher velocity means it has higher energy. When millions of such space objects impacted Earth, almost all of their energy of motion was converted to heat. So, even though these objects were cold individually, the planet they collectively formed was extremely hot. As Earth continued to increase in size and gravitational pull, all its mass was pulled inward toward the center of the planet. This process, known as gravitational compression, created an enormous amount While Earth's hot interior is made up largely of iron, nickel, silicon, and oxygen, it also contains small amounts of radioactive material. These isotopes undergo a process called radioactive decay. As a result, they release thermal energy called radiogenic heat. When radioactive isotopes decay, they initially release a large quantity of energy, but as time progresses, they release less and less thermal energy. When Earth was young, the radiogenic heat produced was tens of times more than it is today. It's unknown precisely how much of Earth's thermal energy came from accretion, friction, or radiogenic heat. However, these heat sources have combined to keep Earth's interior hotter than the surface of the Sun for almost 5 billion years.
Activity. Because of the enormous amount of thermal energy generated during Earth's formation, early Earth was mostly liquid. While the components of a solid planet would not be able to mix and separate, they do mix and separate in a primarily liquid planet. Answer the following questions to investigate some liquids on present-day Earth. Part A. When the following liquids are poured into the same container, they separate as shown in the image. Based on the data in the table below, what caused the order of the layers? A cylinder Peridotite, quartz, and nickel are some of the most common compounds that make up Earth. Peridotite, quartz, and nickel are some of the most common compounds that make up Earth. Peridotite has a density of approximately 3.4 GCm3, quartz has a density of approximately 2.65 GCm3, and nickel has a density of approximately 8.9 GCm3. Based on this information, which compound do you think is most common near Earth's surface, and which do you think is most common near Earth's core? 15.
Earth's interior is extremely hot and under high pressure. In fact, the pressure near Earth's center is 3 to 4 million times greater than on Earth's surface. Scientists cannot recreate these types of conditions in a laboratory. Therefore, we cannot directly observe how Earth's materials behave under this level of heat and pressure. Fortunately, by combining information